Hey, 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 all right, go ahead and grab out your notes that say Geological Time and Process, Part 1, and we'll go ahead and get started there. As always, make sure you're taking notes and highlighting appropriately. Okay, so the first guy we're going to talk about is James Hutton, and this is really just a history. This is the history of the theory of evolution. And so, and I won't ever ask you dates or anything like that. You just want to know the big idea. What did they do? And you can tell here, he said, he said that it's gradual. Evolution is gradual. So he proposed the theory of evolution. And this is that evolution was gradual. It was a slow process. So write in for me, a slow process. And truth be known, he was right. Evolution is a slow process. The theory tries to explain that the earth must be very, very old in order for this to occur. And so it had to have taken, it says, an enormous amount of time. Even thousands or millions of years. So write in for me, millions of years. Because the earth is billions of years old. Okay, so according to the theory, Earth must be, yes, very old. So you want to know that Hutton said gradualism. And gradualism is that the Earth is really old. That's pretty much what you want to know. And so this picture is just showing you mountains. And so in order for these mountains to have formed by evolution, by erosion of water, it would have taken millions of years. And so, and that lines up perfectly with natural selection. And remember, natural selection would be Charles Darwin's theory. And so old mountains appear after hundreds of thousands of years of weathering and things like that. So that's just showing you the different pictures. Okay, Charles Lyell, he was a geologist, which means, write in for me, he studied rocks. Study rocks. Okay, he wrote the book, Principles of Geology. And he says that it's uniform. And basically what this is, and just write this over to the side, history repeats itself. Repeats itself. So like if erosion is happening today, then probably erosion happened 4 billion years ago. And that makes pretty much sense. Okay, so the theory tries to explain that the same processes that are occurring today also occurred in the past. So history, like I said, repeats itself. These processes help to create over millions of years the geologic formations that we see today. For example, erosion. So if erosion was happening then, it's happening now. Again, hundreds of millions of years old. So again, this also supports Darwin's theory. The Earth, Earth is really old. Really old, really slow. Okay. This shows you some new erosion on the roadsides. You can see how the waters ran down and caused that little crease ditch. Okay, and this is erosion over millions of years, like in the Grand Canyon. Man, isn't that pretty? Okay, thunderstorms with rain now. So now there's lots of rain and thunderstorms. And then there's billions of years ago. So if it happened then, it happens now. Okay, so two different ways to tell how old something is. Two different ways to date something. The first one is absolute or radiometric dating. Okay, long story short, what you do is you take the number. Something that's radioactive is releasing subatomic particles. So write that in. Something radioactive releases subatomic particles. Right? Like things that are inside an atom. Protons, neutrons, and electrons. Okay, so something radioactive is releasing those. And so basically, long story made short, they measure how long it takes to release those molecules, or those particles, and however many of those particles there are, well, that's how old it must be. So you're looking at the timing. So you use that time, the half-life is the time, and that's how they guess. And so, for example, they use C14, and C14, weirdly enough, as it radioactivates, C14 will actually make a nitrogen. And so what they do is they're like, okay, if C14 makes nitrogen and it takes 500 years, Well, however much nitrogen there is, times 500, that's how many years. So again, very, very, very estimated. And it's not accurate. For example, they think that the Earth is either 4.5 or 4.55 billion years old. Well, you're like, oh, that's pretty close. That's a pretty good. No, that's 50 million years difference. That's a lot of difference. And so these dating processes are just guessed. You use uranium for anything that's millions of years old. And so uranium actually turns into lead. Okay, so there's a picture of that. It shows you there's your uranium turning into lead. Potassium makes argon, and carbon makes nitrogen. And so they measure these elements, and they're like, oh, well, that's how old it is. Okay, the next one, which is called relative dating, is just like digging a hole, seeing how deep something is. And so if it's, and I'm just going to kind of draw over here on the side, if it's, on the top of the surface, then it died yesterday. But if it's 500 feet down, then it died a long time ago. And if it's 700 feet down, well, then it died before the 500. So the further in the soil something is, the older it is. And so relative dating uses strata. Above that word, write layer. Layer of rocks. And so you're just looking at the different depths that there are. Index fossils are fossils that we know. So, like, we know when the dinosaurs went extinct. So if you're below the dinosaur line, well, then you're this old. And if you're above the dinosaur line, well, then you're this old, right? So that's the dinosaur line is called that KT boundary. And they know, right about where they went extinct. Okay, and then plate tectonics is last. And this is just the removing. Have you ever heard of when the continents were all together in one? That was called Pangea or supercontinent. And so they've been slowly drifting apart, and the collisions are causing mountains, and the separations are causing, valleys or, rivers or whatever. And so this is just like the floors, the mountains or the rivers. So the continental plate, so write in for me the moving of continents. And that's what's causing the different species in different areas, the biogeography. So the subduction and slipping, that's where the plates are pushing together. The continents are pushing together. Okay, I hope this was helpful.